Hello everyone, happy Friday. Today we are going to move on from unit rate and proportional relationships to talk about the constant of proportionality and what that looks like in equations. But just as a fun little brain teaser to get you started, look at this picture. How many cheese balls do you think will fit in that tray? You can see there's one cheese ball sitting there in the tray. So if you want to pause the video to try and figure it out, I will show the answer at the end. Okay, so an update. I have essentially spread out topics that we've learned this year over the next 5 weeks. So today we're talking about the constant proportionality in equations, and then as you can see, this calendar is a little bit different than the one I've been showing you. So through next week we'll talk about proportional relationships, and then we'll move on to percents, and then we'll move on to expressions, and then starting to talk about equations, and then there's spring break technically. So what I'm thinking I'll do is some different types of activities each day that won't be as structured of lessons, and then again to equations, and then possibly an inequalities preview, because that's what we'll be working on when we return to school. So let's jump in. Remember, the constant of proportionality is the constant multiple that relates quantities x and y. What that means is, what are you multiplying blah by to get blah? And we use the letter K to represent this. Even though it starts with a C, constant, we use K. But it's the same as unit rate, because whatever we multiply blah by to get blah, we are also finding that by doing like y divided by x. So we're going to look at some examples here. So first, if you follow me on TikTok, you might have seen this, but we're going to use this as our first example. So yeah. Who let the dogs out? Who let the dogs out? Okay, so Kodiak barked 7 times in 8 seconds. 7 times in 8 seconds. So if we wanted to write an equation to figure out how many times he could bark depending on the number of minutes. So like it's been 20 minutes, how many times could he bark? We're going to figure out his bark per 1 minute. So this is scaling up to figure it out. And this is related to our proportions. So 1 minute is 60 seconds. So we're going to scale this up to be out of 60. And if I divide 60 by 8, I get my scale factor, which is 7.5. So that means that we have to multiply 7 by 7.5 to keep it proportional. And 7 times 7.5 is 52.5. Now, it's hard for him to bark 0.5 times unless it was like a ruh. So we are going to just round that up to 53. So we're going to say Kodiak barks 53 times per 1 minute. So then the way I think about this to write an equation is I think, okay, so if I want to figure out the amount in 2 minutes, what would I do? Well, I'd multiply 53 by 2. Okay, if I want to find the amount in 3 minutes, what would I do? I'd multiply 53 by 3. So that means I'm always multiplying 53 by the number of minutes, and we're going to call that x. And that tells me how many barks, and we're going to call that y. So 53 barks per minute times x, which is minutes, however many minutes have gone by, equals y, and that would be how many barks. Let me tell you, that would sure be annoying if he barked for even 1 minute straight. So this means, looking at our equation, 53 is our constant of proportionality because it's what we are constantly multiplying the number of minutes by to get the total amount of barks. The other way you know it's the constant of proportionality is because it's the unit rate per 1 minute. And that's what we wanted to find, the amount per minute. So y equals 53x is our equation. 53 is the constant of proportionality because that's how many barks per 1 minute. So yeah, let's look at another example. So in this example, this is a picture from yesterday, and my husband and I are repairing a shed that's in our backyard that was old and really creepy. So we have to repair pieces of it, and then we're using the major structure that's still there. But we had to buy plywood. Those are like the big flat sheets of wood that you can kind of see up here, and it's what the sides are made out of too. To replace a panel that was in the back, it was kind of like this that I'm outlining, but in the back. And then, if you can see, the roof looks new compared to the rest. So in buying plywood, obviously it costs money, and for one sheet of plywood that we bought, it was $17. So this is a proportional relationship because every time that you divide the cost by the number of sheets of plywood, you're gonna get 17. Even if we buy 3 sheets of plywood, it's still $17 per sheet. So that means that K, or our constant of proportionality, is 17. Because if I multiply the sheets of plywood by 17, I'm gonna get the cost. And at the same time, like I was saying on the last screen, you can also look at the unit rate, 17. So the way we'd write the equation is y equals 17x. The cost is equal to 17 times the sheets of plywood that we're buying. Okay, so finally, to practice, I have one assignment that you can do called writing equations for proportional relationships. And this kind of walks you through what you need to figure out to be able to write the equation. And just a reminder, if you are doing these assignments, I don't expect you to be able to print them and do them on a perfect little worksheet. Feel free to just pull it up on Schoology, even if it's on your phone, and then just work on the problems on another piece of paper. That can be a great way to practice it without having to print anything, because I don't have a printer at home, so it's totally fine. Another option, again, is the IXL practice, because that can check your work for you, and it just gives you different types of problems online. So, lastly, you came up with an estimate for the number of Cheetos on that baking sheet, and I'm going to reveal the answer. Oh, cheese balls, sorry. 286 cheese balls can fit. That was actually way more than I estimated. Woo! Okay, y'all. After you do this, have a great weekend, and check back on Monday for something else.